Hello everyone, I hope all of you are doing great. In the last episode, I presented how my forward Z posts have an unconstrained axis of rotation which will most definitely result in Z wobble like this. If I move it up or down, you can see the amount of wobble in there. So the question is, how do we fix this? Well, the initial thought I had was to simply use a 4 mm rod that went in one of these holes and was constrained at the top and bottom, which would theoretically constrain this rotation, but it was a bit of jank, so I obviously did not go with it. The proper method would be to use a second linear slide running in parallel to the first linear slide, which would constrain this rotation. So let's jump in CAD where I show you how I came up with this solution. Okay, here we are in the Fusion 360 workspace. As I've already explained that I'm going to add a second slide bearing, and this is just to show that how I'm going to achieve it. This is the slide bearing. I'm not going to get a new part cut. I'm just going to get a connector piece like this, which will connect this plate and this bearing. This in theory should provide enough constraint for this axis to not produce rotation. That's it. That's all the modification I'm going to do to this plate. And one more thing that I had to be very cautious, as I've previously mentioned, Ender 5 Plus frame is extremely space constrained and I have to fight for every single millimeter of printing area. This time I'm using these SHF shaft holders. These are quite different from the last application I did, but this is going to take a lot of time to get made, and these are just easy to make. I'm going to get these cut in sheet metal and then use this as an adapter plate for the SHF mounting, and that should be enough for my application. So here are all the parts needed to fix the Z post. I also tapped these with 5mm tabs, as you can see, and I've only broken one single tap. Would you look at that? I'm actually getting good at tapping stainless steel. Speaking of which, this is the trick I've learned so far. Stainless steel, especially the 304 grade, is actually soft when compared to other grades of stainless steel, but it is still a very strong general purpose steel. The problem comes once stainless steel is work hardened. Then it becomes next to impossible to tap it with standard tools, and worse, laser cutting, which I often employ, work hardens stainless steel since it applies a lot of heat, which again is bad. So the workaround I found regarding this is quite easy. What I do is I get these tap holes cut undersized. Later I use a drill press with plenty of coolant to drill the holes to the required size, which in turn removes the work hardened walls and makes it much easier to tap stainless steel. One more thing I would like to show are these spacers that I use for the SK shaft holders. The problem with these holders is that they are 14mm wide and they usually sit on a 2020 extrusion. And once these are tightened, they mostly lie on the slot itself, which has very little material behind it to provide proper support to these. So when I use these, it provides a much more uniform distribution of load and in turn extends the life of the extrusion itself. With this out of the way, let me assemble these parts and I'll show you the end results. And well, as you can see, the Z-axis is now done and that pesky rotation in the axis is now taken care of. Now join me in the next episode where I implement the XY axis and share some exciting new innovations with you. Until then, bye.